Yes, for the audience, I would like to say that I encourage you to write questions to the chat box. You can write those questions in Finnish or in English or even in Swedish. And Maria's and Johanna's presentation takes about 40-45 minutes, and after that we have time to discuss about results and those questions you have raised to the chat box. So I think that we can start, and floor is yours.
Okay.
Yes. Johanna, you should start.
Yes, I will start briefly, and yeah, and welcome to this presentation and webinar that we will tell a bit about a scientific article that was published last year on nutrient management and farm balances on Swedish organic and conventional farms. We both were authors on this, but it's based mainly on work that Maria and co-author Eva Salmon did a couple of years ago. So I will just tell you a little bit about epoch. Yeah, and then you change them.
Yes, and it's here. Yes, here it is. Fine.
So epoch, this sister organization that Sari said, is SLU's Center for Organic Food and Farming, epoch short name, at the Swedish University of Agricultural Sciences. And we are a national interdisciplinary knowledge platform for organic food and farming. And our main aim is to communicate research-based knowledge on organics, also initiating and coordinating research and contributing to education. And we're not doing research, but we have like connected the researchers working with us that summon this or like this scientific knowledge into different like seminars, syntheses, and fact sheets. And we also have a newsletter you could follow that comes out every third week. And if you want to read more, you can also follow this link. And I'm the director of epoch, and Maria was the director before me. So now I hand over to Maria.
Thank you very much. So I just say a few words that I've been mostly involved in research on the cropping system and farming system level during my career, with a special focus on nutrient management in organic farming. Not the least nitrogen fixing crops and green manure. And as Johanna said, I was the director of epoch during 10 years before. And I want to say that one of the first questions behind our analysis of the balances was the assumption that this tool is a good indicator of risk of losses to the environment. There are also quite a lot of evidence international that you can use the balances to approximate risk of losses. And we also thought it was important to gather basic facts to get a fact-based picture of nutrient flows on real Swedish farms. There have been quite a lot of nutrient balance studies. Many of them are based on model farms and field experiments. And of course, there are also studies of real farms, but it is a lack in Sweden, the scientific publications on this matter. So that was our background, and so we did we compiled a survey on N and P balances on Swedish farms, and it was published in Organic Agriculture last year, as Johanna said. And I would say this it was based on the data we got from a database that the Swedish Board of Agriculture is responsible of, and the Swedish Board also financed part of this study. A small background. Let me see here. It's quite many farms, 2,500 around. It's both dairy and arable farms in southern Sweden, and both conventional and organic. As I pointed out, the data was collected in a project, still ongoing project, Focus of Nutrients, hosted by the Swedish Board of Agriculture. And the data was collected by farm advisors between in the beginning of the 20th decade. So I will also want to say that there are more recent data in, for example, in a report from the Swedish Board of Agriculture that show the similar pattern, as these are a little bit old data. So the figures, the balance results are quite stable and robust during the years. And we also have concentrated on dairy farms and arable farms. And dairy farms, they should have most of their animals, more than 75%, in dairy production. And arable farms, they have less than 0.0 animal units per hectare. They can have some animals, but small amounts. And then from this database, we analyzed more thoroughly the farm gate balances. It's basically outputs minus inputs, and also nitrogen use efficiency on these farms. And the data also was elevated to overcome the difference in size of the farms, so that small farm they do not affect the size of the farm, do not affect the results. So it's based on area. And also, of course, we also did statistic analysis of the data. Here you can say the number of farms, the organic ones, are much fewer, and it's the situation in the database. It's 78 organic dairy farms and 56 organic arable farms, and much. Let me see. I should remove that. Much more in conventional farms, but still there are quite many organic farms if you compare with other studies. And it's these three counties, they lie in southern Sweden, and the project Focus on Nutrients had the aim of, you can say, lower the N and P losses in Sweden, and we also have the largest eutrophication risks in the southern Sweden. So that is the cause that is so many farms in the most southern county, which is Skåne. You also can see the average area on the farms, that the organic dairy farms are have larger areas than the conventional, and the opposite is true for the arable farms, that the conventional are larger. And shortly about the cropping systems, if if you compare the organic and conventional dairy farms, there are not as large differences compared with the arable farms. Of course, the lay and pulse crops dominate a little bit more on the organic dairy farms and a little bit less cereals. It's also so that, at least in Sweden, the proportion of the feed are more based on forage in organic farming than in conventional farming. So that's a clear difference. But the arable farms, the crop rotations are very, very different, as also the arable farms have quite a large proportion of lays and pulses. Some of the lays are green manure, and some are fodder lays, and they sold to neighbors. And the conventional ones have small areas of lays. Yes. Now I want to show the main nutrient flows included in the analysis, and it's you will see more in the tables that there are a few more flows, but these are the main flows to show the different kinds of inflows and outputs. And as it is farm gate nutrient balances, the manure on farm is not shown in the balances. It's circulated in farm, and that is very valid for, of course, both organic and conventional dairy farms. And here you can also see the main influence on dairy organic farm is fixation and feed. And a bit surprisingly, maybe, the conventional dairy farms import also large amount of mineral and mainly N fertilizers and more feed than the organic ones. And also you can see here of the areas that the outputs are larger on the dairy farms. So it's more intensive production, you can say. I also want to say that areas are not strictly representing values. It's a schematic figure. On the arable farms, it's, as I said earlier, or even more differences in structure between organic and conventional. The mineral N fertilizers on the conventional arable farms. And in Sweden, the organic arable farms, they import quite a lot of organic fertilizers and also grow nitrogen fixing crops. There are quite large differences in output also. So it's the organic ones are more extensive, you could say, in an input output perspective. And then we have these balances end up in surpluses, most often surpluses, you could say. And it's it could be, as I began to say, an indicator of risk of losses, but you also have other explanation. This soil NMP accumulation also lay in the surpluses, and this is not measured. And now I come to the results of the flows of nitrogen and phosphorus. And I start with the dairy farms and nitrogen. It's quite a lot of figures, and you can study these more in detail if you read the paper. I want to point out some things here. I can say also that first I can say that most components differ significantly between conventional and organic. but it's not shown in this table. On the dairy farm, here you see the large inputs of mineral and fertilizers on the conventional farms, and the fertilizer input to the dairy farms, organic dairy farms, are much smaller. And actually, the median for the fertilizer input on organic dairy farms is 0. So it's most of the farms does not import organic fertilizers. It's quite obvious. And the nitrogen fixation also differs very much. It's three times higher on the organic farms. And if you remember, the proportion of leys and pulses didn't differ as much as these N fixation inputs. And it is because of the leys on the organic farms. They are more clover rich, have much higher proportions of nitrogen fixing species. And here you also can say, and we concentrate on the farm inputs on this table, that the feed import is quite not so small on organic farms, but much larger on the conventional ones. Now we move to the same figure and focus on a little bit other things. Yes, this ends up with a 80% larger input on the conventional farms. And the output here you say 35 contra 67 on the conventional. It's much lower. But here you also can see, I want to point out that the conventional farms both produce milk and livestock products and crop products. And much less crop products are sold from the organic farms, and that have implications that I will comment further on. And here you also see that the surplus, despite the larger output, the inputs are so much larger that the surplus ends up to be 70% larger on the conventional farms. Yes, and here you also have the nitrogen use and efficiency for the dairy farms. And we have counted the efficiency based on animal production as to make a more fair comparison between organic and conventional farms. This model of calculating an efficiency has been done before, for example, by Dalgaard in Denmark. And here you see that you have actually somewhat higher efficiency on organic farm, and especially in Skåne. And I also here you see the large variation. Each point is one farm, and so much more farms were conventional. But still you have a quite strong correlation with N input. And you can say that the intensity, the land-based intensity affects the surplus. Not all of the inputs end up in products. So this, you can also see that there are a lot of work to be done to be able to use the surpluses, and that is a high variation between farms. And now some words about the phosphorus on dairy farms. you can see the feed proportion. It's quite a large part of the input. And here you see the phosphorus input. It's a little bit similar despite the Skåne farms, in organic Skåne farms. And if you remember, the input of nitrogen fertilizers was 8 to 9 times higher on the conventional dairy farms. And here is not as large differences. And that is, of course, depending on that it's organic fertilizers imported to the organic farms, and that contains both nitrogen and phosphorus. On the conventional farms, they mostly import nitrogen fertilizers. We come back to this figure once more and see the surpluses. On average, they are, as for the nitrogen, lower on the organic farms, and it's mostly because of the higher feed import to conventional farm. And here you see also that the Skåne organic farm stands out a little bit, even if both organic and conventional farms in Skåne have lower surpluses. So they both have lower inputs of phosphorus in Skåne and higher outputs. A lot of figures, more figures. Now we turn to the arable farms. And here you see that they import fertilizers, organic fertilizers, mostly farmyard manure from neighbor farms, but also some other organic fertilizers, including biogas residues. While the conventional ones, they mostly use mineral nitrogen fertilizers. And the nitrogen fixation is quite low on the conventional farms, but in the cropping system of our organic arable farms, you have quite a lot of green manure or lace or clover for seed. So it's the main inflows here. And as for dairy farms, it's higher inputs. It's more intensive production on conventional farm, not surprisingly. And also to note that the output is almost double on the conventional ones. And also the surplus is larger on conventional farms, but not at the same magnitude as for dairy farms. So it's I think it's a little bit more unclear, the performance of the arable farms, except from Skåne. You see that they have quite large outputs compared to the farms in the other counties, and also quite remarkable lower surplus of nitrogen. And the last picture concerning nitrogen is about nitrogen use efficiency of crop products. And it's mainly crop products on these farms, but there are small amounts of animals also, as you can see. It's quite well known that the nitrogen use efficiency often are lower on organic arable farms. But as you see, the Skåne farms, they have almost the same efficiency as the Skåne farms the conventional ones, the organic. And you can discuss that, of course, why it looks like this. And one explanation could be that in Skåne, the soil and climatic conditions are favorable for decomposition and nitrogen mineralization from organic fertilizers and from green manure material and crop residues. And also I know that often the organic herbal farms in Skåne, they grow less green manure, so they sell crops from a higher proportion of their land compared to counties further north. So that could be one explanation. Also, yes, the correlation between inputs and surpluses are not as strong for the arable farms. Especially you have a weak correlation on the arable farms. You see it's just a big cluster. So here you can say that it's very different between large differences between the farms, how they reach the goal of low surpluses. I think I don't comment that further. And the phosphorus flows on arable farms, it's a special case, you can say, Sweden. You see the phosphorus inputs on the arable farms through organic fertilizers are quite high. And despite the outputs are much lower. And as I mentioned before, you get often too much phosphorus, more than you want and need, but you need the nitrogen. So if you want, if you have the rates of fertilizer adjusted to nitrogen need, you get too much phosphorus. But it's also depends what kind of organic fertilizer you use. Well, I should also mention that in these years, when the data was collected, quite cheap, pea-rich bone meal was available on the market. So many organic farms, they bought this pea-rich fertilizer during these years. And this resulted in a quite large surplus of phosphorus. It's, you can see here, the surplus are positive 5 kilograms and negative for the conventional farms. The project focus on nutrients have compiled later, more recent data, and there you can see quite much lower surplus on organic arable farms. If I remember right, it was about in 3 kilograms, 2 to 3 kilograms. But still, it's positive, and you can see here that the Skåne farms, they did not have the same strategy. You can say less import of phosphorus, and also a higher production that ended up in much smaller and surplus on the Skåne farms. And here also you can see that on the conventional farms, you have a negative surplus. And that is not very strange, actually, because many of the soils in Skåne have very good phosphorus status due to, you can say, an over-fertilization, historically over-fertilization with phosphorus. So the soil could deliver phosphorus without so much phosphorus fertilization. Yes. Now I have come to a summary. And as I started, the cropping systems mainly on the arable farms are very much different, with high proportion of and-fixing crops, even on the arable farms. And the input through nitrogen fixation, about 3 times larger on dairy, 4 times larger on arable farms. So it's very important input, of course. And much larger, both nitrogen and phosphorus inputs on dairy farms, and larger inputs of fertilizers on conventional arable farms. And also I have pointed out the outputs, so larger outputs and lower nitrogen surpluses, mainly on dairy farms. More difficult to be very sure of the higher surpluses of organic arable farms, I would say. And about the phosphorus, lower in organic dairy, but higher on average on organic arable farms. And I would also say the high nitrogen use efficient on organic dairy farms are just is quite promising. But there are more challenges concerning the efficiency on the organic arable farms. And I think we come back a little bit to this in the discussion, Johanna, to penetrate these results a little bit more. So, discussion and questions. Johanna, shall we start that?
Yes, so let's see if we can pin us, the two of us, above the presentation, or should we take away the presentation? I think it would be good if the presentation could be still there.
Shall we just start anyway? So.
Oh, no, I just pinned you. I'm trying to do this. Wait, I will see if I can. Yeah, like that. I did it.
Okay.
Yes, now we'll have a little discussion, me and Maria, or I will ask some questions. And then after some time now, then it will be in the end also possibilities to put questions from you participating or like the audience. But I start. And what would you say from this study is the main reasons for the differences in surplus between the production systems? And can you say if this is general differences between organic and conventional? Is it typical for Sweden, and what would you say like in a more international perspective?
Yes, I think the main reasons on the dairy farms, I must say it's the large inputs of both farmyard manure that is not actually shown, but they use their own farmyard manure. And on top of that, they use quite large amounts, surprisingly large amounts of mineral fertilizers. I think that maybe this lead to a bit that the manure is not used in the most best ways. Perhaps there are spread uneven on the farm area, more manure close to the farm center. It's a speculation, and mineral and fertilizers further away. So that is one main reason, I think. And also the feed import. All these inputs put a risk of a high nutrient load on the conventional dairy farms that may not be it don't end up in products as it would be, as you would wish. And I also talked about on the arable farms, the organic ones having high phosphorus surpluses. And here you have to look at the input of what kind of organic fertilizer you use. Maybe we come back a little bit more to that in a further question here. And I think internationally there are quite a lot of studies on dairy production, and it's you can say a consensus that conventional dairy farms have higher surpluses in many countries, even if the systems may not look exactly the same. The surpluses are quite much higher in conventional dairy farming, and there are almost no studies internationally published on arable farms. Very few. So you have not so much to compare with there. So I actually not know really that about the arable farms. And all these balances are from the southern parts, 3 southern counties in Sweden. And I think as the data has been quite robust over time, it's quite general results that is valid. But I will also say that organic dairy farms further north and also far north, we could not really tell. You cannot generalize, because they may have a little bit of other cropping systems, even more maize and less cereals, for example. So that we can't say from this study.
Thank you. And the nutrient use efficiency, that is also important. And what can they say about this from the study? Or what can we say from this?
Yes, I think we can say it is shown that the organic dairy farms, they have a quite sustainable nutrient use efficiency. Maybe it's possible to get a higher, I don't know, but it often is in these areas. The values are quite good, I would say. Concerning the arable nutrient use efficiency, on average quite low. Of course, some of the reason for this could be that you have organic fertilizer, you have maize, and you have a soil nitrogen accumulation. And this is not accounted for in this study. But also it's a challenge in organic farming to synchronize the nitrogen mineralization from all these organic sources to crop needs. Many crops need a lot of available nutrients early in spring, and it could be difficult to get the soul working so early in northern country like Sweden. So it's quite difficult to achieve a very high nutrient use efficiency on a year basis for organic fertilizers and plant residues.
Yes, and about these nutrient balances, what is it you can say? What are the values from this, and what is maybe difficult and drawbacks with this?
I want to especially mention one thing. It's the uncertainty of some of the data. The nitrogen fixation is calculated in a model. It's a really developed model, but still it's based partly on observation in the field, for example, of the proportion of clovers in lace. So that is a weak point and will affect the results of the balances. So that's one thing. And another thing, which is a drawback of this farm gate or on-farm balances, is that off-farm inputs like feed, for example, on animal farms, are not taking into account in these on-farm balances. The off-farm production of feed cause also surpluses, and some studies have included this, and if the feed import are larger on conventional farms, as it is in this study, it will lead to even larger differences between conventional and organic, and thereby strengthening our conclusion of a larger and surplus on dairy farms. I think there are quite high values of making these calculations. At least if you have a longer time period that you make these calculations, and also many farms, as each farm is in a way unique. So you have to, if you want a general picture, you have to analyze many farms. And as the focus in the project focus on nutrients are to lower the losses, they perform balance calculations several times on the same farm, and they have an improvement work, and they, through the balances, they count them on the same way and do them repeatedly. Then they can have these balance calculations as a tool for improvements, and it's also coupled with advisory service on the farms. So I finished there.
Do you think also that this farm gate NP balances, that they are valuable indicators for risk of losses to the environment?
We have not studied that in our project here, and it's almost impossible to do that on real farms. You can have models to for estimating the losses, but there are some other studies that has pointed out that in the long term you have large surpluses. It affects the losses, but a single year, the balance of the single year doesn't tell much about the losses. You have to see it in a longer term, and both even phosphorus, if you year after year apply more phosphorus, then it's of course a higher risk of losses even of phosphorus. So if you do it with care, I would say it's a quite good indicator. Then you need to maybe also measure in more controlled experiments. So.
And from this and the numbers and the results, can you say some suggestions for both organic and conventional agriculture regarding a more sustainable nutrient use?
Yes, I mean, it's a very big question. It could be an own seminar, but to improve, I mean, the organic arable farming, there, I think the management of organic fertilizers and plant residues are crucial, and it's not easy, but I think we need more efforts, and also then the yields and the outputs could be higher if we just succeed better in managing organic fertilizers. And also I think it has happened quite much during the recent decades of which organic fertilizer is available for organic farming. And if you could use organic fertilizer more with more available nutrients for the nutrient management in springs, in the spring mainly, you could improve the use of nitrogen. So it's a big thing, and also the nitrogen crops, the residues from nitrogen fixing crops, is also crucial for nutrient management. And sometimes if you have a whole year green manure and plow under very large amounts, it's difficult to manage that sustainable. So you can, for example, it's been shown that if you intercrop legume crops with non-legume crops, you have more possibilities to have a more effective nitrogen use. And also catch crops. Their catch crops are used, but both in organic and conventional farming. And maybe you could extend that also. So, well, it's a lot of things to be said. Say also on conventional dairy farms that the local, to increase local on-farm or near-farm feed production will make it more easy to use the farm's manure in an effective way. So a closer connection between feed production and the animal production would promote a better nutrient management.
Thank you. We got a question on a clarification, and it's from Tina Olofsson that works with this focus on nutrients. That is what you said about the feed, the drawbacks of nutrient balances, and we can't, or it's not included the surpluses from the feed production. Just that the nutrients in the feeds are included, but it's the losses of nitrogen and surpluses when producing the feed. That's what you meant then.
that is what I meant. And yes, it's almost impossible in this, if you have very many farms, to get data on the surplus of feed production. But if you have a more intense data inventory on a few farms, it is more possible to also look into off-farm feed production, I think.
So now soon we should let, if there is any other questions, you're welcome to put them in the chat. But as a last question to you now, do you have any other overall conclusion of the results that you want to mention?
You asked me? Or?
Yes.
No? Yes, I think it has been very interesting to work with all this data, and you realize very much that every farm is unique, but there are general system differences, you also can say. So I think it's very valuable to see these large flows, and as there are a high variation between farms, there are possibilities for improvements. But sometimes I will also just add a side comment that sometimes the economic reality stops the possibility to improve nutrient management. It could be very nice fertilizers, but too expensive, very suitable fertilizers, and so on. And I mean, in Skåne, it's very interesting in Skåne to see the figures there. And of course, it's high producing soils. And it would be interesting to dig more into the difference. I don't think the farmers are more skilled in Skåne than in other countries, or what do you say, Stina? It's more it's other things, and maybe, as I said, a big thing is that it's difficult with organic fertilizers in the north due to slow mineralization rates, and therefore maybe the availability of more easily taken up. It's not really maybe in the organic ideas, but you have also to adjust the organic practices to reality, or to the climatic conditions and so on.
Yeah, I would like to comment that I really liked that your research, because you had that regional comparison, which is very, very important when we are talking about organic farming. I also agree that probably climatic conditions may be have a major effect on at least nitrogen use efficiency. Like in Skåne you have shown in your presentation. Luke has done also long-term trials in Toholammi field, and there are two kind of organic crop rotations and also conventional rotations. Another is for dairy farm, and another for arable farm, and we have seen quite similar actually results from those trials, where they have also assisted nutrient leaching, and our results are such kind of that there is about 20% lower nitrogen leaching from organic arable farms compared to conventional arable farm, but the difference between dairy farms is smaller. So I think
yes.
that it's very logical. But that trial has been conducted in quite north. It's in Ostrobotny area and in Finland, so it's quite north. But yes, this is important to try to find to try to conduct trials in different parts of Finland as well.
And I think also that you need more detailed field experiments and other kinds of experiments to improve different techniques as a complement to these whole farm studies. And to improve the internal flows on farm that is not captured by the nutrient balances. So it's a complement. It could be just to capture the flows on real farms. It's a valuable tool, I think, and to be able to have so many farms included, like in this project by the Swedish Board of Agriculture. I don't know if you have the same type of project in Finland, like the Swedish Board of Agriculture and the Focus on Nutrients project. You have such a, because this is a very large database, and that get bigger and bigger each year.
Yeah. I guess that it's we have had at least researchers concentrated in nutrient balance studies, but at the moment there are not so many working with these topics, at least in our organic research network. But it's very important topic. Is there another question? Okay, thank you, and I think that we have already used our time.
Yes, we have.
Time is 4 o'clock. I warmly thank you, Maria and Johanna, for your presentation. This is really nice Nordic collaboration, and let's continue this collaboration. It was so nice to hear about your results.
It's good that you invited us, and we could. Maria had the chance to talk about this study.
Yes.
Yes. Yes. Okay. Is it so that Heidi want to show one slide more, or
should you
shall I stop? Oh, here.
Okay. So I think that our next webinar will be held in mid-April, 10th of April, and it will be unfortunately only in Finnish. But then we are actually concentrated to arable and actually experiments done in different arable crop varieties in northern Finland. So welcome all to follow our next webinar. Thank you. Kiitokset kaikille.
Thank you.
Thank you very much. Bye bye.
Okay. See you.
See you. Bye.